I want to draw a picture about the Wagga Shopper data and just show you what's going on with this hypothesis test. Get all the right tools and I'll be right. Okay, so we know from our data that we have a normal distribution, and our hypothesized value is 156. So we're hypothesizing that the sample, all shoppers, from Roy Morgan, we're told that all shoppers spend $156 a week on groceries, and we want to find out based on our sample whether this is true or not. And so we've gone out and collected some data, and we found that our mean was out here somewhere at 169.50. So these are all dollars. Okay, so we found from our hypothesis test that this distance here, and it's totally out of proportion, is 13 standard deviations between these two numbers. 13.3. So t was equal to 13.3. So we know that our value of 169, which we found in our sample, is 13.3 standard deviations away from $156. And so what does that mean? If it was not different, then it would be within 2 standard deviations roughly either side. Okay, so remember the scale of this is way out here. And so we know from what we know about normal distributions that this shaded in area in red is 95%. So it's like we formed a 95% confidence interval between this number and this number. If our value from our sample lies between within this range, then we've got evidence to support that the 156 is the mean amount that's spent on groceries. However, our sample, 169, does not support this. In fact, it's a long way away. It's 13.3 standard deviations away, and if we look at 13.3 standard deviations away on either side, we can work out how unlikely that is to happen. So what's the area that's left after we move out to 13.3 standard deviations away from the mean? So this value here and this value here added together give us the p-value, or sig, the significance level that we get in the output. So the significance level, or the p-value, tells you the area that lies beyond or outside the value of your sample. And if it's very small, so if it's smaller than 0.05, if it was 0.05, it would be in that area there. But if it lies, if your mean is even further out, then it's going to be smaller than 0.05. As soon as you reach this point here and this point here, either side, you're willing to say there's enough evidence to suggest that the mean of your sample is not the same as 156, and that's exactly what's going on with this hypothesis test.